In this video, we're going to look at parallel and perpendicular lines. Now, let's first examine the two equations I've got on here. From previous videos, you should know that this here is the gradient, and this is the intercept. Now, the gradient is also called the slope. It tells you how steep a line is. So if we think logically, if lines are parallel, they must be the same steepness. In other words, they must have the same slope. So the bit for the parallel line that's got to be the same is the gradient. So for parallel lines, we know the gradients are the same. Right, let's put that better. Parallel lines have the same gradient. That's what makes parallel lines parallel lines. So in this particular case, an equation that would be parallel to this would be something like y equals 5x minus 7. It wouldn't matter what I put here as long as it wasn't plus 3. These two lines are now parallel because they have the same gradient. Now, it's not always as straightforward as that, because if you look at this second one here, we can't immediately say what the gradient is. The temptation is, well, it's the number in front of x, isn't it? So it must be 9. Remember, it's got to be written in the form y equals mx plus c first. We need to make y the subject of the formula. So how do we go about doing this? Well, the first thing I want to get rid of is that plus 7. So I'm going to subtract 7 from both sides. So 3y is equal to 9x minus 7. Now I don't want that 3 in front, so I'm going to divide by 3. So I'm going to divide everything by 3. So y would equal 3x minus 7 over 3. Once again, what did we say? We've got to have the same gradient. This is the gradient. So my parallel line would be y equals 3x plus whatever we like. And I'm going to leave it blank because that is still parallel, because that one just goes to the origin. So when we have parallel lines, the gradients must be the same. And you must make sure it's in the form y equals mx plus c before you establish what the gradient is. And that's all you really need to know about parallel lines. So let's look at an example where we use that fact. So you could be asked to write down the equation of a line that is parallel to 2x plus 3 and passes through a point. And let's make that point 1, 4. So this is hinging on what we did before. So if it's got to be parallel to y equals 2x plus 3, it must have the same gradient as 2x plus 3. Well, what is the gradient? Well, the gradient of 2x plus 3 is 2. So I need to make sure it's got that as its gradient. So the first thing I know is my equation is y equals 2x plus c. I don't know what that c is yet, but I do know the gradient. Now, like we did before, we're going to substitute the points 1 and 4 into this equation. So where I see a y, I'm going to put the y value, which is 4. Where I see an x, I'm going to put the x value, which is 1. Now I solve for c. 4 is equal to 2 plus c, which leads me to the conclusion that c must be worth 2. So what was the equation of this line? Well, it's y equals, gradient we said was 2, so it's 2x, plus my intercept, which is 2. And the equation of the line parallel to y equals 2x plus 3, passing through 1, 4, is 2x plus 2. So we identified the gradient, popped it in, substituted the point in. And that's what you need to know about parallel lines.